Good morning all. Today we learn about the hash table. The hash technique is the last topic of this last unit, unit 5, unit 4. So before knowing the concept of hash table, first you understand what is the hash function, what is hash address, what is hashing. In case all of you know that the tree tables means at the time of heap sort or the tree sort, we had already seen that the two types of sorting, max heap and a mean heap. So in the tree table, if you want to search any particular identifier, then you have to then you require the number of comparisons to search the particular given element. But in this case, hash function. Hello, am I audible? Hello.
Yes, ma'am.
Okay. So in case of the hash table, the address of identifier is generated using some mathematical formula. Address of identifier means the any variable. The address of that variable is computed using the particular mathematical formula. And what do you mean by the hash function? So for that the hash function is used. Hash function means the function. Suppose I denote here the function as f of x, which is used to generate the address of identifier using some mathematical formula, is called as the hash function. Again, I repeat, the function which is used to calculate the address of identifier is called as hash function. And what do you mean by the hash address? The address which is generated by this f of x, or address which is generated by the hash function is called as the hash address. The hash address is also called as the home address. The hash and home are the synonyms of each other. And now the next definition is hash table. What is the definition of hash table? The identifiers, the memory where the identifiers are stored is called as the hash table. First of all, you understand the basic terms related to the hash table, the hash function, then hash address, and then hash table. The definition of hash table is the memory where the identifiers are stored is called as the hash table, and it is denoted by HT. Hash table is denoted by HT. As it is a table, the table is divided into the number of rows and columns. And the hash table is denoted by HT. This table is divided into the number of rows and columns, and the rows are called as buckets and the columns are called as the slots. So all of us aware about the concept of table. It is nothing but it is the combination of number of rows and column. In the very similar way here, the hash table is divided into the number of buckets and the slots. Now we learn about what are the different methods to design the hash functions. For designing the hash function, there are the various different methods to design the hash function. First of all of you must know that the for calculating the address of particular identifier, you require the concept of hash function. So for calculating the addresses, there are the various methods to calculate the hash address. So for designing or for the number of methods which are to be used to calculate the hash address, first of all, you understand that there are the two important properties. The first important property is that always remember that your hash address is generated unique. Means for two non-identical identifiers, it generates the different address. Or two non-identical, or you can say for the two different. Non-identical means what? The different. For the two different identifiers, two different variables, the hash address should be different. And the second property is that it design as simple as possible. And you remember that at the time of designing the hash address, it do not takes the more time to calculate the address. Do not take more time to calculate the address of identifier. So these are the two properties. The first property that is very important and is that design the hash function such that the two non-identical identifiers generate the different address. म्हणजे दोन जर वेगवेगळे व्हेरिएबल्स असतील तर दोघांना वेगळाच ऍड्रेस यायला पाहिजे. भलेही दोघांच्या नावाची सुरुवात सेम लेटरने होत असेल तरी सुद्धा त्यांचा ऍड्रेस डिफरंट असायला पाहिजे. मीन्स इट जनरेट्स द युनिक ऍड्रेस. इट जनरेट्स द different address. And the second property is we have to just keep in your mind as the hash function or it is or hash function or hash address which is calculated that is as simple as possible. Means it do not require the much more time to calculate the hash address. So these are the two important properties that should remember at the time of calculating the hash address. So there are different methods for calculating the hash address. The first method is the division method. Then second method is division method. Then second method is folding method. And third method is fold boundary method. Fold boundary method. So these are the various different methods with which you can design your hash address. So out of which we see the first method, that is a division method. With this division method, you have to use the mathematical formula as h of x equal to x mod m plus 1. As I already told you that the hash address means the address which is generated by the hash function. But it uses the concept of some mathematical formula to calculate the hash address. So for this division method, this is one of the formula. With this formula, you can find out the hash address. Here x means the identifiers and m means it is just the integer division. Suppose I take here one example. Suppose the value of m is given and that is a 31. X, the identifiers are given as 100, 101 up to 105, and then you have to calculate the hash address. Hash address means h of x. So how to calculate this mod means all of you know that this modulo is one of the arithmetic operator and which is generally used to find out the remainder after the division. Means if you want to know the remainder, then you use the modulo operator. So according to this formula, I here put up the values. You see h of x equal to x. X means suppose I take the first value 100, then mod, then m, the value of m is 31, okay, and then plus 1. So what will be the value? Modulo operator, when 100 is divided by 31, the remainder is 7. 31 3s are 97. 31 3s are 93. So 100 minus 93, that is equal to 7 plus 1 and that is equal to 8. So the hash table is, this is h of x. First column is x and the second is h of x. The identifier 100, 101, 102, 103, 104 and then 105. These are the various identifiers and the calculated address for the first identifier is 8. As these are all these identifiers are sequential, means 101, 102, 103. So there is no need to calculate the hash address for each and every identifier. You can directly write down 9, then 10, then 11, then 12, and then 13. If there is a difference, If these identifiers are not in sequential order, suppose 100, then 110, 120, then every time you have to calculate the hash address using this formula. Correct? But these are given in a sequential order, then you can just calculate for the hash address for the first identifier, and then accordingly you can write down 9, 10, 11, 12, and then 30. So this is the first method. Now the second method is folding method. So the second method is the folding method. So what this method does, once again, all the calculation of the hash addresses is based on the some mathematical formula. Once again here, the folding method, the technique of folding method is divide the given identifiers into the similar length of the parts. Suppose for example, I have the different identifiers 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose these are the given identifiers, and now you have to find out the hash address for all the identifiers using the folding method. So this method tells you that first of all you have to divide the all identifiers into the number of parts using the same length. Suppose here I want to the total identifiers are 9, so I make the 3 parts. This is the first part, this is second part, and this is the third part. First, second, and then third. Then this method tells you that you just add all the parts ignoring the carry, and after addition whatever the answer with ignoring carry, that is the hash address. So how to do? Suppose see, these are the 3 different parts. Now you just add all these. I start from the last part, 7, 8, 9 plus 4, 5, 6 plus 1, 2, 3, and you just do the addition. 8, then 13, 14, 15, 16, then 11, 12, and then 13. 1 is the carry, so ignore that carry. If carry is there, then you just ignore the carry. And what will be the address? The address is 360. So h of x equal to 368. So this is called as the folding method. The little variation of this folding method is the boundary fold boundary method. Fold boundary method. So there is a little variation, means there is a little change in the fold boundary method. Again, I take the same example. You have given the number of identifiers, you just break it into the number of 3 parts with the same length, 3, 3, 3. Now this fold boundary method tells you that you just reverse the boundary digits. The boundary digits means the first group and then third group, and then you do the addition and ignore the carry. So first and third are the reverse. So you just reverse the digits. So instead of 7, 8, 9, I write here 9, 8, 7. The second part as it is, that is 4, 5, 6. And third part, it is also the boundary part. Boundary parts 1 and 3 means first and last. You just reverse the digit. So digits are 3, 2, 1. Because our part is 1, 2, 3. You just reverse the digit of the boundary part 1 and 3. And you just do the addition and ignore the carry. If 7 plus 7, 14. Okay. Then 5 plus 8, 13, 14, 15, and then 16. Again 10, 17. 1 is carry. So the hash address is 764. 764. Okay. This is called as a generated address. Okay, so these are the 3 different various methods generally used to calculate the hash address: division method, folding method, and a little variation is fold boundary method. Now the next topic is collision. So what do you mean by the collision? So in case, suppose if you have the if the identifiers having the same alphabet, then there may be the possibility to generate the same address. And if the more than one identifiers are generate the same address, then there is the collision. The collision occurs. So what is the concept of collision? Collision means what? Collision, suppose for example, here I take one example. Suppose I have some of the identifiers G, A, then D, then A, G, L, A2, A1, okay, whatever it may be, then A3 and Z. Suppose I have the given number of identifiers. These are the given number of identifiers. And now I, first of all, I create the hash address. And suppose I have the one bucket and two slots, suppose. So there are the number of 26 parts, suppose. Okay, 1, 2, 3, 4 up to the 26 parts. What happens? Suppose I calculate the address of GA, then address of GA. G is the alphabet. All identifiers are the alphabets. So G, what is the number of G in a sequence in alphabet? 7. A, B, C, D, E, F, G. The G is at 7 locations, so it generates the address 7. So 1, 2, 3, 4, 5, 6, 7. So the GA is located at the 7th bucket. Now the D. So similarly, the D having the 4 and A having the address 1. So at 1, at 4th location, the D is allocated, and at the 1 location, the A is there. Okay, now again the G. Suppose I have only one slot and one bucket. I have one slot and only one bucket. Sorry, not bucket. I have the 26 buckets. See, these are the 26 bucket, but I have only this one slot 1. I do not have the slot 2, slot 3, and slot 4. So in that case, what happens? When I calculate the address of G, once again, you find out what is the position of G in the alphabets. Again 7. So see here, this 7 and 7, both are similar. When I go for the 7th bucket, then it is filled with GA. And again, the G calculates the same address 7. Now the question is that where I have to add, because this is already filled. So this is the collision, and this is called as the collision. Means there is no space for the newly identifier because both identifiers generate the same address, and this is called as the collision. Now to solve the concept of collision, there are the two different types of the techniques. The first technique is the linear probing method. Collision resolution technique. Collision resolution techniques. So to solve the such a type of collision, we have the two different methods. The first method is linear probing method. Linear probing method. So once again, for this linear probing method, I take the same example as previous example. So for the explanation of linear probing, I take again the same identifiers. The first identifier is GA, then B, A1 suppose, then E, A1, E, then A2, A3, Z, A4, and then Z, A. Okay, suppose we have given the number of identifiers like this, and if the collision occurs, then how the linear probing method will work. This is our point. So once again, here I consider I have the 26 buckets. Why 26? Because the total alphabets are 26. So that's why here I take the 26 buckets and only one slot. This like the previous same example. So, okay. So the number of buckets 1, 2, 3, 4, 5, 6, 7, 8, 9 up to the here Z means 1, 2, 3, 4, 5, 6, 7, 8, 9 up to the 26. And now you just hash the number of given identifiers into the memory by calculating the hash address. How to calculate the hash address? The formula is calculating the hash address f of GA. Here you consider always for calculating the address the starting position of the starting letter. If you have given the alphabets, then you consider the position of that first letter into the alphabets. Again here the first letter is G and it is located at the 7th position in the alphabet A, B, C, D, E, F, G. So 7. Then you calculate the D. f of d equal to 4. Then A is located at the first position, so 1. Then E is located at the fifth position. Then what about A2? What about A2? Again, the starting letter is A, it generates the 1. What is A3? Again, just 1 minute. I continue the next part. So f of A3, once again A is starting letter, it generates 1. Then f of Z, it is the last letter, so 26. Then f of A4, again it generates hash address 1. And f of ZA, it again generates the 26. Okay. So in this case, now how to solve the resolution collision? So f of GA equal to 7. So GA is allocated at 7th position. Then f of D is at location 4. So here D. Then A is here 1. Then E is at 5th location. F of A2 equal to 1. See here, the collision occurs. The first bucket is filled with A, and again the next identifier A2 generates the same address 1. Now the question is that where I have to where I have to keep, or where I have to put this A2, because 1 is already filled. So here the collision occurs. Now, this linear probing, it is also called as the open addressing method. Open addressing method. So what this method tells? This method tells you, you successively search the next empty location for the colliding records. Now here colliding record is A2. And what is the next empty successive bucket? This second. So here I just put up A2. Okay, now A3. Then once again, you go for the next empty successive place, next empty successive bucket. And here the A3 is at third location. Okay, now the Z is at 26 location. Okay, now A4 equal to again 1, means again the collision. But you just search for the next empty location. So next empty location is 6. And now you just accommodate at A4 here. And the last f of ZA. Again here the collision occurs because already the 26 is filled with what? It is filled with the Z identifier. So there is no space to accommodate ZA. In that case, we have to consider this is the circular hashing, and that's why you successively search for the next empty location. Yes, this is the next empty location, and you just put up here the ZA. So this linear probing method solves the problem of collision. How it solves? It is also called as the open addressing. Means you just successively search for the next empty bucket, and successively means sequentially you search for the next empty, and you just put up the next identifier. So with this, the collision is resolved. This is the first method. Now the second method is the separate chaining method. But here what happens? What are the drawbacks of first method? The drawback of first method is actually as we hash the identifiers in the next successive empty bucket, it forms the clustering. Clustering means the group. See, just like A1, A2, A3, then Z, ZA. So like that, the clusters means the groups, and it becomes a very difficult to delete the elements also. So these are the drawbacks using the linear probing method. So to overcome these drawbacks, we have the another method. That method is called as the separate chaining method. Separate chaining method. Separate chaining method. So what this separate chaining method tells you? Once again here, I take the identifiers as suppose here, just 1 minute, I take the same identifiers again here, the same number of identifiers, means GA, then D, A1, E, then A2, A3, Z, A4 and ZA. The same example here, once again I take the same example. You have given the number of identifiers and now you use the separate chaining method to resolve the collision. Resolve means to solve the collision problem. So what this method tells? This method tells you that if the collision occurs, then you have to maintain the separate area. That separate area is called as a secondary area, and into that second area you have to put up the newly collided records. Actually, it uses the concept of pointers, identifier and then pointers. It maintains the two types of the areas, primary area and secondary area here. Suppose this is the primary area, and this is a secondary area, secondary area. Okay, in that primary area, you have, just 1 minute. Now, in the second method, collision resolution technique, in the second separate chaining method, this method tells you that to maintain the two different areas, primary area and secondary area. The primary area consists of the two columns, identifier and then pointer, means it consists of the two parts. The first part is for identifier and second part is for the pointer. And here it has the number of different memory addresses, suppose 3, then 4, 5, 6, 7, 8, 9, and suppose 10. So this is the primary area. Again in secondary area, you have the same parts, identifier and the pointer. The first part is identifier and second part is the pointer. Once again here, its own addresses, suppose 100, 101, 102, 103, 104, then 105, 106, 107, 108, 109, and 1110. Okay, so these are the various number of memory locations for the primary area and the secondary area. Very similar to the first method, you have to just calculate the address of particular identifier and just hash it, just keep it. So the first is the GA. So GA, what is the address of GA? 7, because the starting letter is G and the position of G in the alphabet is 7. So at the 7 you just keep it GA. Okay, now next is, again, if there is any identifier, you check if there is any identifier that starts with G. No. So in the pointer field, you just write the null, because pointer is, it indicates the address of next. So for GA, for there is no any colliding record that starts with the G. So that's why I keep the pointer null, means the cross. Now the next D. For D, the address is 4. Now you check if there is any available another identifier that starts with D. No. So that's why you just keep it cross. Now A, what is the address of A? It is 1. Now you check if there is exist any other identifier that starts with A. Yes, here too. So now again it generates the address 1, collision occurs. But here the solution is that you have to just take the any random address from the secondary area to store the next colliding record. See here once again in the last similar example, A, A2, A3 and A4 having the address 1, and already the one location is filled up. There is no space to accommodate the other A1, A2, A3 and A4. This is the collision, and the collided records are collided records are A2, A3 and A4. Now you store all this A2, A3, A4 into the secondary area by giving the address in the pointer. Suppose for example here I take suppose A103. The meaning is that the next identifier that starts with A, that will be stored at the location 103. So like this the collision removes. Like this the collision resolves. So now you go for the next E. What is the address of E? 5. So you just write down here E. There is no any other record identifier that starts with the E. So you just keep it cross here. Now A2. Yes. Again A2 having the same address 1, but 1 is already filled. So you just look at the pointer field. Pointer has given 103. So the next colliding record is stored at 103, and that is the A2. Again you check, is there any other identifier that starts with A? Yes, there is a A3. Now in the pointer, you just give here 105. What is the meaning? Means at 105, the next colliding record, that is A3, will present in the 105 block. Again, you check, is there any identifier that starts with A? Yes, A4. And now here, suppose I write here 100. So what is the meaning? The meaning is that at 100th location, the next colliding record is stored. That is A4. Now again you check, no, there is no any identifier that starts with A. So you just cross. Means you just put up the null value in the pointer. The meaning is that there is no any identifier that starts with A, and hence the collision removed. The collision is resolved. Now Z. What about the Z? The address of Z is 26. Suppose here the address of Z is 26. Just I have the total. I consider here the total 26. Suppose here I write dash 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 dash, and suppose this is a 26. So at 26 I accommodate the Z, and there is no any. Yes, there is again one next identifier that starts with ZA. So I give here the address in the secondary area. The address in the secondary area, suppose I give here the 107. Okay, 107 or 106. The meaning is that at 106, the next colliding record that starts with Z is accommodated. So what is ZA? Then ZA. There is no any identifier that starts with Z. So you just keep it null value. So this is about the separate chaining method. Two methods. The first is the linear probing method. In that linear probing method, you have to search for the next successive empty bucket to place the colliding records. But there are the two drawbacks. The first drawback is it forms the clusters, means the grouping, and it becomes very difficult to search the particular identifier. The second drawback is it is again difficult to delete the element. Now these two drawbacks are overcome in the second method, that is a separate chaining method. And separate chaining means what? Chaining. This is a chaining, and this is a separate chaining. Means in this method, the two separate areas are maintained: primary area and then secondary area. And here in the primary area, first of all, you calculate the addresses of identifier, and you keep it all the identifiers according to the address generated. Now you successively check for each and every identifier. Is there any other identifier that starts with the first similar letter? Suppose it is GA. Then you check whether there is any other identifier that starts with G. No. If no, then you just put the null value, because there is no any other identifier that starts with G. For the A, sorry. For the A, the address is 1. But you check, is there any other identifier that starts with A? Yes, there are the other identifiers, A2, A3, and A4. And hence here, you use the pointer field. You just give here the any random address from the secondary area. This secondary area is also called as the overflow area. Means it contains, the secondary or the overflow area contains all the colliding records. Colliding records are kept at the secondary area. So the next is a A2. Suppose here I give here 103. At 103, the next identifier will keep here. Then now again for there is another A3. Then again I write here the any random value from the secondary area, and that is a 105. So at 105, the next identifier A3 will be stored. Again there is a one identifier that starts with the A4. So that's why here I take one random value 100. The meaning is that at 100, the next colliding record A4 is here at 100 location, and there is no any other identifier that starts with A, and therefore I keep here the null value. So this is about the separate chaining method. And here your whole syllabus is completed here now. All the 4 chapters are completed. If you have any doubt, any query, you just go through all the videos, go through all the chapters, you study by heart. And if you have any problem, you note down and you tell me. According to your difficulties, I will arrange one revision lecture in the next week. Also, I will provide you one question bank for whole the chapters. You go through this whole question bank. Okay. Now, if you have any problem, you can ask me. Otherwise, I stop here. Thank you very much.